All right, hello everybody. Welcome back for part two of Simplifying Expressions. So here we have a couple geometry applications. So in this case, what we're looking for is we want to find the perimeter of each of these figures as an algebraic expression. Now the side lengths aren't given as just basic numbers. Instead of knowing the sides are 12 and 20 and 80 or whatever, here we have them as algebraic expressions. So this length is x. And whatever x is, this length is 2x minus 3. This length is 3x minus plus 2. Now, I don't know what x is, but in this case, it really doesn't matter because we can combine these into one algebraic expression for the perimeter. And then if we someday know what x is, we can plug x in. And if we don't, who cares? We still have a nice expression for the perimeter. So perimeter just means length around a figure, right? Which means all we're really doing is adding the side lengths up. So take a minute, pause the video, see if you can find the simplified expression for the perimeter of this triangle, and likewise the rectangle below. Keep in mind in a rectangle, right, opposite sides have to be congruent to each other. See what you can do with that. Go ahead and pause it, try those expressions. And then when you're done, come on back. All right, welcome back. Did you pause the video? Did you want to pause it? Okay, let's see how we did. So in this case, I'm going to add these three side lengths together. So I'm going to say x plus 2x minus 3 plus 3x plus 2. Here are our three side lengths all put in one expression that can now be combined with like terms. So I'm going to go through and identify some like terms. We have an x. We have a positive 2x. Remember what I said in the last video about keeping the sign that's in front with the number. And I have a positive 3x as well. Now, this x in front, when you have a variable that's by itself, it's assumed there's one of them there. So while there isn't a number there right now, I'm going to put the number 1 in there because that's what we really have. We have 1x plus 2x plus 3x, which gives us a total of 6x. And in terms of the number part, I have a negative 3 and a positive 2. Negative 3 and positive 2 give me a negative 1. And that is our expression for the perimeter of this figure, 6x minus 1. Don't fall into the temptation of trying to say that 6x minus 1 is 5x, because unfortunately this 1 back here doesn't have an x on it, and this 6 does. So those two are not like terms. This is as simple as that one's going to get. Sound good? How'd you do? Yeah, you got it? Nicely done. Give yourself a nice high five. Did other people in the class look at you and wonder why you were clapping in front of your face? Maybe. If so, you're welcome. All right, so down here we have a nice rectangle. Now rectangles, opposite sides are congruent, so this length, if it's x squared plus y, then so is this one over here. And if this top side is 2x plus 3y, so is this bottom side down here. So now what we can do is we can take those four things and add them all together. So that expression is going to look like this. 2x plus 3y plus 2x plus 3y, because I have two of them, and then plus x squared plus y plus my last side, x squared plus y. Now we're going to go through and combine some like terms. So I'm going to start with the x squared terms. I have two of them. They're both positive 1x squared, positive 1x squared, which gives me a positive 2x squared. Now I have some x terms in there too. So we have a 2x, and I have a positive 2x. And unfortunately, that's going to be it. So I'm going to combine those two and give us a nice 4x. Now, y's, we have a bunch of them, right? So I have a positive 3y, another positive 3y, a positive 1y, a positive 1y, which gives me a total of positive 8y. And that is going to be the perimeter of our rectangle. That's as simple as it's going to get because, once again, my x squared and my x are not like terms. Even though they both have an x in it, the squared makes it a different term. Look good? All right, excellent. Let's move on to the next page. So this page is an interesting one. I like this page a lot. So there are 5 examples here, and each one has an algebraic expression that can be simplified. And something seems to have gone wrong in these examples. They combined it. Some crazy person came over and simplified each of these. It was me. But they combined things horribly wrong. I did. So what I want you to do is identify what happened in each of these, what went wrong, and try to fix it. See if you can get the correct answer for the simplified version of each expression. So I'm going to give you a minute to pause the video, try it on your own, see if you can identify what the mistakes are in each. Then come on back and unpause the video. All right. Have you paused it? Okay. Hopefully you're back, you've simplified it, and you're ready to see if you were right. So in this first example, we have a 4x plus 8x. Those are definitely like terms. We can certainly combine them. But what this crazy person did is they combined the two x's and made it an x squared. But we know that that's not the case. These are x's, and x just tells me the things that I have. The numbers in front tell me how many I have. So 4x plus 8x can be combined to make 12x, and that's our final answer. In the second case, we have a 6d and a plus 10. Does this 10 have a d on it? It doesn't, which means I can't combine it with the 6d. So if this were 10d and 6d, then I would get 16d. But unfortunately, that 10 can't be combined, so that is as simple as it's going to get. This one actually can't be simplified any further. That's our answer. Doing well so far? I hope so. Let's take a look at the orange one. So in this case, it looks like what they did is 12y plus 7, and maybe they combine those two and get 19y. Then minus 3y would give me 16y. But, just like the last example, that part doesn't have a variable. The 7 is not a like term. The 12y and the negative 3y, those two can be combined. 12y and negative 3y would give me a 9y. And then my plus 7 unfortunately just stays at the back. It doesn't have a y on it, so it doesn't get to join the party. Sorry, 7. Maybe next time. All right, in the next example, we've got some a's and b's. And it looks like this person did the right thing to combine the a's and combine the b's, but they didn't listen to that rule of combining and keeping the signs with each number, right? So we have a 2a and a negative 5a. The 2a is positive, the 5a is negative. That's actually not going to give me 7a. That's going to give us a negative 3a. Likewise for the b's. We have a negative 5b and a positive 2b. Again, negative 5 and positive 2 are going to combine to make a negative 3. So this isn't right either. Minus 3b. That's what we want. Okay. This last example, I have a 2x squared plus 4x plus 3x. Now, looks like they all have x's, which is true, but unfortunately that x squared term is a little bit different than the other two. By positive 4x, positive 3x, those two can be combined, but the 2x squared can't. So that's going to be what they did wrong here. The 2, 4, and 3 gave them 9, but then they gave us weird x to the 4th. Don't do that. That's crazy talk. So I'm going to start with my 2x squared. That comes over. And then we have our positive 4x. Positive 3x gives us a positive 7x. And that is our simplified version. Sound good? How'd you do on those questions? Did you get a 5 out of 5? You did? Oh, man. You are a brilliant student. Nicely done. All right, that is going to end our simplifying part 2. I hope you enjoyed, and I hope you learned something great. See you next time.